So this video is a lecture explaining how to take or how to determine the pH or the hydrogen ion concentration or the hydroxide ion concentration, all that type of stuff. All right, so calculate the pH for a specific hydrogen ion concentration. Let's say it's given that it's 1.45 times 10 to the negative 5 molar. So how do we do this? So as you saw at the beginning of the video, there's different equations we can use. So if we're trying to solve for pH, pH is the negative log of the hydrogen ion concentration. So that means pH is negative log 1.4 times 10 to the negative 5. When you do this and you put in your calculator, so how do we do it? So negative, push this log button here. So then 1.4 second, comma, for the double E, negative 5, close parentheses. I end up with that number there, all of that. However, remember there's sig figs in chemistry, so based on your, it can be either based on your concentration or on your pH. So based on what you're given in the problem, according to this concentration, I have a total of two sig figs, which you see that. So just bear with me on this one. You do your calculation and it says 4.8538. So I'm going to tell you that your answer is now going to be 4.85 for the pH. So the number of sig figs is either based on the coefficient that's given in the problem, or like the number of sig figs in your concentration, and then after the decimal of the pH, that's where you start counting sig figs. So don't count the 4 or the number in the front, but start from the decimal place and count how many sig figs that is. All right, so calculate the hydrogen ion concentration from a known pH if it is 8.5. So just by looking at this, just so we know, our pH is 8.5. I have only one sig fig at the end of it. So that means my final answer can only have one significant figure. So to find H, concentration of H plus equals 10 to the negative pH. 10 to the negative 8.5 equals the following. So how do I do this? Find on your calculator, usually it's by the log button, so second, that button there. So I have this cursor right here. Sorry, I'm gonna put negative 8.5. So I got 3.16 blah, 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 times 10 to the negative 9. So remember, I have one sig fig according to this. So how to make it only one sig fig? Well, my coefficient will only have one sig fig. So 3 times 10 to the negative 9. And this is a concentration. That's what I want to find. So my unit for concentration is capital M for molarity. Box it in. Question 3 in your notes. What is the pH and pOH of 0.0235 molar HCl solution? So just so we're clear, when you're dealing with pH or pOH, this says HCl. So when HCl is put into solution, it ionizes into hydrogen and chloride ions. So the pOH, this concentration is related to the pH. But how do you get the pOH? Well, there's different equations for that, and we'll see which one we need to use for this. So the first thing we can calculate is the pH. So the pH is the negative log of the hydrogen ion concentration. So it's going to be 0.0235. So negative log so the pH is going to be 1.6289 something. However, according to this, I have 3 sig figs. So after my decimal, I only have 3 numbers. So equals 1.629 is my pH. How do you get your pOH? Well, remember, one of the equations is 14 equals pH plus pOH. Just solve for pOH. 14 minus 1.629 equals my pOH. So 14 minus 1.62, oops. 12.371 is my pOH. What is the pH of a 6.2 times 10 to the negative 5 molar NaOH solution? So notice here, remember we just said, so pH is related to something that produces hydrogen ions. Here, I don't produce hydrogen ions, I only produce sodium and hydroxide. So in reality, we're actually going to calculate the pOH first, and then find my pH afterwards. So this is the negative log of, pOH is negative log of my concentration. Oops, negative log of 6.2 times 10 to the negative 5. Sorry, I couldn't see it, my bad. So this is the pOH. I got 4.207 something. 2 sig figs though. So after the decimal, 4.21 is my pOH, I'm sorry. Which I don't really want per se, but I'm boxing in, my bad. So to find the pH though, you're gonna take 14 minus your pOH. So 14 minus 4.21. I end up with 9.79 for my pH for this. Find the pH if the hydrogen concentration is 0.0001 moles per liter. So this is actually molarity. So my concentration, my hydrogen ion concentration is actually 0.0001 molar. So if I find the pH, pH equals the negative log of the hydrogen ion concentration. So negative log of 0.0001 close parentheses or brackets. So negative log. So I end up with 4, but I have 1 sig fig here. So 4.0. Find the pH of 0.03 molar solution of hydrochloric acid. So same concept. So pH is the negative log of, so this is hydrochloric acid. I'm going to produce hydrogen ions and chloride ions here. So again, these are pretty straightforward. 0.03 is going to be in the bracket, so negative log of that. I have 1.5228 something, 1 sig fig, so 1.5 for my final answer. All right, if you have any questions, please let me know. Thanks.